Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are graphing real polynomials, cubics, quartics. Who knows what's going to happen? Let's get to it, shall we? Okay, I really like this graphic. Lots of good information. You should pause and just take a quick look at it. We are going to move forward. Talking about cubics to start with. If we have ax cubed and a is greater than 0, the cubic's going to look like this, and if a is less than 0 negative, it's going to have the general shape of this. All of this, good stuff. It's kind of obvious how if we cross the x-axis 3 times, we're going to have 3 different roots for the cubic and some coefficient a. Here we're going to have one root and then a repeated root because it cuts it here and then it touches it here. Here the cubic cuts the x-axis in a very kind of flat, maybe strange way, and that's going to turn into x minus the root cubed. And then here it cuts the x-axis one time, and then it doesn't other, and that's going to indicate, or it doesn't anywhere else, I should say. And that indicates we're going to have 1 real solution and 2 complex solutions. And we can figure that out by x minus alpha times ax squared plus bx plus c, because it's going to come from a quadratic. So let's use some common sense, get to it here for part A. We're going to find the graph, or find the equation from the graph. We have 3 roots, clearly, -1, 2, and 4. So we know that y is equal to a times x plus 1 times x minus 2 times x minus 4. We also have this handy-dandy point here, 0, -8. So that means when x equals 0, y equals -8, so that's a times 1 times -2 times -4. Solving for a, we get a equal to -1. So the equation of our cubic is negative x plus 1, x minus 2, x minus 4. We are not asked to put it in any particular form, so we can leave it like that and expand it as necessary depending upon the situation. Here we have a root at -3 because it cuts the x-axis. Here it touches the x-axis at 2/3, indicating a repeated root. So we are going to have y is equal to a times x plus 3. And to get 2/3 as a 0, then our factor would be 3x minus 2. And again, it's a repeated root, so that would be squared. We also have the coordinate 0, 6. So substituting 6 in for y, I'm not going to go through this again, and 0 for x, I will tell you that we get a equal to 1/2. So we have the beautiful cubic 1/2 times x plus 3 times 3x minus 2, the quantity squared. Moving on. Again, you might want to pause and look through this. The big thing here is if an x-intercept is not given, then we should go ahead and, well, we have a k here, so clearly that's x minus k squared. And since it's a repeated root, the other one is going to be to the first power, and it is generally easier to list the factors ax plus b instead of put the a out in front, because you would have to distribute it through, and a times b is a constant anyway. So we just go ahead and list it as b. If there is only one root and we're going to have complex solutions, then we should list the other factor as a quadratic. And we're going to know that the discriminant is less than 0 because we're not going to have any other real roots. So find the equation of a cubic which cuts the x-axis at 2 and -3. So we know we're going to have y equals, let's see, x minus 2, and putting the a out front, that remains to be determined, and then x plus 3, and the y-axis at -48, so we have 0, -48 that the equation or the graph goes through, and which passes through 1, -40 as well. So we don't have another root, so we're going to throw in ax plus b there. And of course, a cannot be equal to 0. Otherwise, we don't have a cubic. All right, so we know we have 0, -48. So if we substitute those in, 0, -48, we substitute this into the equation, we end up with -2 times 3b equals -48. So solving that, we get b is equal to 8. We also have the point 140, so that would give me the equation -1 times 4 times a plus 8 is equal to -40, and that's just by substitution. How do I know that this is 8? Just solve for b equals 8 right there. So we get the equation a plus 8 equals 10 after we divide by -4, giving us a is equal to 2. So now we have the equation with a equal to 2. Y equals x minus 2 times x plus 3 times 2x, 2 for the a, 8 for the b, plus 8. Very nice. And if we want to have the a out in front, we can factor the 2 out of this and get 2 times x minus 2 times x plus 3 times x plus 4. All right, there we go. All right. What about quartics? Same sorts of ideas as with cubics. A quartic could have a maximum of 4 real zeros. It's always going to have 4 solutions, whether they're real or complex. But it's the same idea as the cubics. So for here, I know I've got a real here, I've got a repeated root here, and it looks like, oh, another one here, so this isn't too bad. And then a y-intercept. I thought we might have a little bit of fun, with some complex solutions. So now we're going to have y equals a times x plus 3 times, this is repeated because it touches, so that's going to be x plus 1, the quantity squared, and then, of course, x minus 3. When x equals 0, we have the point 0, -3. Substituting into here, we can solve for a. I will tell you that a equals 1/3 instead of boring you with algebra that you know how to do. So y would be equal to 1/3, and we really should list the squared first, descending order of powers. X plus 1 squared, x plus 3, x minus 3, and we have the equation of our quartic. Find the quartic that touches the x-axis at 2, so that's going to be x minus 2 squared. Cuts the x-axis at -3, so that's at x plus 3. And then we do not have anything else to give us another root, so we're going to go ahead and throw in ax plus b, because x times an x squared is going to be the 4th power, which makes it a quartic, which they tell us right here. Then we go through the same thing as before. We know that p of 1 is equal to -12. So that means -12 is going to equal 1 minus 2 squared times 1 plus 3 times A plus B. And if we solve for A plus B, then we're going to get -3. How do I know to just leave that alone and not distribute? Well, if I have two unknowns and no way to get rid of one of them with a 0, then I know that I'm going to need another equation besides this one. So I'm going to call this equation 1. I also know that P of 3 is equal to 6. And if I substitute all that in there, please trust me that we will end up with 3A plus B is equal to 1. We'll call that equation 2. And equation 1 and equation 2, a system of equations. Again, I will not bore you with the algebra. It gives A equal to 2 and B equal to -5. So I end up with some polynomial P of x is equal to x minus 2 squared times x plus 3. My A is 2, so that's going to be 2x. My B is -5. Boom, chugga-lugga-lugga. All done there. So I think that's a good place to wrap it up. That's the end of part 1, and we shall continue with part 2. See you then. I am out.